to the problem statement. Okay, so if there are no questions, I hope you have all understood what is being asked. So we have to accept a string, basically just a collection of words, and then you have to see if there is at least one word in this sequence that occurs exactly n times, right? So the confusion could be here, at least one word and exactly n times here. So let's see what Rajneesh has written. So can you explain, Rajneesh, what you have written here?
Yes, sir. So first we have taken a console of the para in a form of list. Okay, and then we have assigned count as 0, and then we have iterated through the length of the list of list C. Okay, so we compare each element with every element of the C, and then we have increased the count. If it is found, then we have increased the count. Now we have checked whether this count is matching with the n or not. If it is matching, then return true, and if it is not matching, then return false. This is
Okay, right. So I'll ask the rest of the learners here. Can someone point out what could go wrong with this approach?
Sir, in line third, it is comma, but the string given is space separated.
No. I think in line 7, Rajneesh, I also solved just now. My problem is the same problem with you. Just now I solved. In line 7, what you have is Ci equal to Cj you written. So the same word get compared and counted as 1. Instead of that, you write Ci equal to Cj plus 1. And in the range, you write len of C minus 1. That's all. It's done.
Okay, so yes, that's the correct point. So see, Rajneesh, what Shomit mentioned is correct. See, you are comparing the same word with itself, right?
yes, sir.
So I would what I would suggest is what a slightly different way to solve the same problem is if I is not equal to j, and make sure you are not comparing the word with itself, and make sure that you increment count for every other case.
And can we increase the j loop from 1 to len of C?
And that also works, right? So in that case, you don't need to have this I not equal to j. So we'll do both the approaches. We will try this out first. So I missed something. Is it space separated? And did I give comma? No, right? So okay. So that is
Space separate.
It is space separated.
okay. Then how is this even working in the first place?
Sir, only false was coming true.
Oh, okay. So let's just change it. Okay, so this passes how many test cases?
One test case only.
Okay, so why is this?
Sir, if one word on I is equal to 1 and the other one is j is equal to 3, I is equal to 3, then 1, 3 and 3, 1.
Exactly. Yeah, that's a good point. Yeah, so then this is not the correct way to fix it. So we have to start range from I plus 1, right?
I2, yeah.
Okay, so let's just try this. Let's see if this fix works.
Yes, sir.
Okay. Make sure it works for. Okay, we are missing one more private.
So
I think one count is increased, sir, because the word itself is not.
Okay, that's a good point.
Yes, sir. So count will start from 1.
But see, there is I think a more serious problem here. Can someone else point out what?
So shouldn't count be incremented inside the I loop, because after checking one word in the I loop, we'll be resetting the count. Otherwise, it will just get added to the previous count.
Exactly. Yeah. So that is next problem. So we have to maybe some commenting will help.
I think one more problem.
Yeah.
Sir, if n is equal to 3 and we have one word where the maximum count is 4, then
very good. Yeah, that is the other problem. So what should happen to this particular block? Should it be inside?
No, this has to be outside.
Just the return loop will be inside the for, and the else loop outside the for. so that we get and count is greater than n.
Good. Okay. So this return, this part should be inside the loop, but this should be outside. Okay. So
Yes, and the return false is outside the loop.
yeah. So let's just try this. So let's just try this. This anyway seems to work. So no problem there. Okay. This.
Sir, I
It
think
should be
return
count
false, it
greater
will be
than n,
always
not
work.
count equal to n.
1 second. So we need exactly n, right? At least one word should occur exactly n times.
Exactly. So
Count
if
should be
condition is
initialized
outside,
as 1 because like we are counting the first word.
yes,
Exactly.
sir.
Okay.
Count should
Yeah.
be equal to 1. Yes, that makes
So many back and forths, but it's worth it. I think. Let's just go with this. We are still missing something. What could that be?
so if condition.
So
I
just
think we
yeah,
should check at last.
just hold on, sir, just 1 minute.
I'm not
Why
sure
is a count equal to 0? What's the problem? I don't know.
because the same element cannot be counted, which we are comparing.
No, we should start with count 0, na?
See, I am going from I plus 1, right?
Yes, sir.
So I'm the first word of, so what we are exactly doing is C of I, right? So that is the word. So that we have already counted. So we start with count equal to 1. And then we see if in the list C of I plus 1 to end of the list, is there any word which is equal to C of I?
Same thing,
Sir,
but
sir,
Yeah,
if we have count is equal to n, then we should break both the loops, I think.
that is not needed, right? See, if count is n, then I just return true. Once you return, you exit out of the function itself. So
Yeah. Okay.
Okay, so what are we missing? Let me.
Sir, let me count greater than or equal to n. He mentioned that at least n times the word should be repeated.
No. So there is at least one word that occurs exactly n times. So the number of repetitions should be exactly.
If I may interrupt, I did it using dictionary, sir.
Yeah. So the dictionary is easier solution. We'll come to that.
But sir, I did the same logic. Instead of the same code, instead of count 0, I count 1. I started with count 0, and what you did, I plus 1. Instead of that, I check the Ci of j equal to Cj plus 1, and the range is len of C minus 1. But mine is work.
Okay, tell me your code. Let's modify this.
So that count equal to 0.
Okay.
And then instead of I plus 1 in the j, you start with len of C. No I.
Okay, just length of C. Okay.
Just length of C minus 1.
Okay.
And in C of j, you write C of j plus 1. That's all. That's what I did. It's worked.
Okay, can you tell me the logic behind what you have done?
Sir, what I am doing, I am checking the first element with all except first all other element. If I found, and then I increment the count, and accordingly I am checking that. This is the logic only. What you did the same thing, but I have done this way and mine is worked. Means I passed all the test cases.
Okay, so you are, so I will just make certain things clearer here.
In this, if I is equals to 1, then it will compare itself with Cj plus 1 because j starts from 0. So C1 equals to J1, C1.
Right. So see, we are missing something here. Since this is not the solution I wrote, I'm also not able to get into the zone of this particular answer, but this is a valid approach.
So I think I understood what was wrong in the previous case. So we were considering, like, if we started from the first word, we were comparing the first word with every other word in the list. So like if we are at second word,
Right.
we'll be starting from third word and comparing till the end of the list. But what if there is a word in the middle which is present in the starting as well? We're not counting that.
Right.
So like for the inner
No,
loop, the J loop, yeah. For
J
the
loop
J loop,
always lane
no,
of C minus 1 means J loop always starts with 0.
yeah, your approach is correct. In the previous approach,
Oh,
when
acha,
J
acha.
loop was starting
Okay,
from
okay.
I plus 1, so we were
Yeah,
essentially missing
correct.
out all the previous elements. So what if there is one word in the middle of the list which is
Yeah, you're
present in the
correct.
starting as well?
Okay.
Yes.
I think that will be managed by I.
No. So
No.
so this is count. We'll have count as 1. We'll start from. We'll go through all elements except I. Right. So if j equal to I don't want to.
J not equal to I, then we enter this.
So if I is not equal to j and c of I double equal to c of j, so will this work? Is this correct?
So I think same condition 1, 3 and 3, 1.
1, 3 and 3, 1. Yeah. So this is what we were actually facing, right? How do we? Okay, we are counting pairs a comma b and b comma a as the same thing. Okay, so one way could be we could do this. Will that work?
No, sir.
What if I see? Okay, just stick with me. This is important. Like, see, there is another solution using dictionaries which avoids all these problems. But I just
Sir, I
want.
simply created a set and then compare the elements of the set.
Yeah, but yeah, right. So I totally agree this, but I want to get this working. We have enough time, so let me just take this example, and we are looking for something that occurs exactly 3 times, right? So if we start with say good, then how many pairs will I get here? So I'll get good comma good, right? And I will end up. No, right. So this, what is this 1 comma 3, 3 comma 1? Can you come again, Shahid? Shahid, right?
So why you are going for pairs? I don't understand.
No. So that's what I got confused a bit. So let's just stick to this. Okay. Like we'll see if this works. I might have confused a lot of you, but please stay with me. Okay, so this is the correct one. I got carried away by this pairs business. So see, the pairs is not a problem. Okay, what all that we are doing here is we are going through each word in the list or in the sequence, and we are just checking how many words in the list match with this particular word, right? And we could either do it 2 ways, right? We could set count to be 1 and have this condition I not equal to j, or we could even say count equal to 0 and get rid of this. Okay, so let me just verify if that works. Okay, so that also works, right? So the both ways of doing it are equally valid. So is there any confusion here? So I might have ended up confusing some of you. So you can just let me know if there is any confusion with this solution.
No, sir, I understood because you give count 0 because it is comparing with itself. One element is comparing itself and then it is counting. Yes, sir. Good. I understood.
Yeah. So any other confusions with respect to this solution?
And one more thing, sir. Can we put the if loop outside the for loop? If count is equal to and then return true.
Which line?
13th line.
Yeah.
Can we put it outside the loop?
No. If we put it outside the loop, there is a problem, right? So for example, so I'll in this case, consider this test case. What will happen is for choice, right? Choice happens to be the last word in the sequence. So count will be 1 because there's only one item,
Yes, yes.
right? So you have to have it the moment you find a word which satisfies the condition, you have to terminate the function itself.
Yes. Okay, I understood.
Sir, I have a question.
Sir, I have a question.
Okay,
Sir,
there are two
in
of
line
them.
16.
Sir, I have a
Yeah.
question.
Hello, sir.
Yeah.
Sir, in line 16, will it not work always?
In the sense,
In the sense, it means uh, while it returning true and it will return false.
no, you can only execute one return statement in a function.
Okay. Okay, sir. Thank you.
Okay.
Sir, I have a question.
Yeah.
Smita here. Sir, first there is a good. So for I in range length C, first start with good. And then we count and all these things are right. Then again we on the L equal to 0, 1, 2, third position. When we go to the third position, again there is a good. So how many times there is a good? It will again counter and it will return true, true, true. So we are not removing the good. Whatever the element there is present, we already checked for that element. We are not removing it. So we can do it with the dictionary.
Yeah. So I'll come to that solution. That is probably a simpler solution, but this is just because we started with this and we were not able to get this working. I was spending some time on this.
Sir, in the same code, I have changed a bit. In the 13th line, instead of equal to n, I have written it as not equal to n, return false. And in the 16th line, I have written as return true. I am passing all the 3 private test cases, but failing in one public test case, sir.
So you're saying if you have replaced it as
false. Yeah, false. And 16th line as true.
but that is dangerous, right? If you do this,
I just wanted to try what happens.
Yeah. So if this, we can maybe construct a test case where this will fail. If count not equal to n, return false, right? So for example, I will just swap the position of word and good. So let's say this is the word, this is the sequence. Okay, so you will the first time you take up, it will be word. You will see if word is there in any of the other places. So the count at this stage will be 1, right? When you come to line 13.
Yes, sir.
So 1 is not equal to 3, therefore you will return false and you'll be done there itself.
Okay.
Right? So that's why it has to be, yeah, w equal to n, you return true. Yeah. So any other questions regarding the solution?
So we are checking in J, we are checking for each word. Means we are taking the I, suppose 0, code we are taking, and then we are checking if there is a good any other position it is there, and then we are counting this.
Yeah.
Incrementing the count.
Yeah, we are checking if a particular word is there in the list multiple or any number of times. It could be 1, 2, 3.
So, sir, if J is also 0, I is also 0, then will this be counted or the J will
it will be counted.
Yeah, it should be, right? J, if that is what happens in the case of good. If I and J are 0, you count it.
In line number 10, it's a counted.
Okay.
Okay, so now what I'll do is I'll just I'll just present the dictionary solution and we'll move on because we have spent enough time on this, right? So whenever it comes to something like frequency, right, you are essentially trying to find out the frequency of each word in a sequence, and you need to check if some word has a frequency equal to n, right? So remember that we have done frequency so many times, right? So let's say words equal to para.split. So we can leave it as it is. It will split by space, but just to be explicit, we'll do this. And then you initialize an empty dictionary. And for each word in the list, if the word is not yet a key in the dictionary, you create the key and set it to 0, and outside you increment the key, right? So that will make sure that you have the frequency that you need. And now what you do is you go through each key in the dictionary and ask if the frequency of that particular word is double equal to n. If that is true, you return true. And finally, if for no key this frequency is equal to n, you return false. Right? So I'll just run this code, make sure it is correct, and then get back to any questions regarding the code. Okay, so this is the dictionary approach. So any questions here?
In line number 12, we are iterating through the keys.
Yeah.
We have made the dictionary and we are checking if that value of that key is equal to n, right? Key is my word and the value is my this frequency. Right?
Yeah.
Okay.
So we can also do if n in frequency dot values, just return true and else return false.
Yeah. So typically what I have done is I have avoided using other functions, but you can, if you know these other extra methods, right, you can always do that. Okay, any other doubts or questions regarding this dictionary based solution to this code, to this problem?
Sir, can we even use sets?
Yeah, anything. So anything that works. You could use sets. You could. Yeah, that also works.
Sir, could you please check my answer, sir? Now I'll post it in chat box.
See, if it works, then you are it passes all test cases, right?
So no, sir. I'm currently in my mobile phone, sir. I didn't check that, sir.
Okay, please check that, and we'll get back to that in the end, because like there are we have discussed this in 2 different solutions, and I would like to move on to the next one now. At the end, I will get back to this.
Yes, sir. Thank you, sir.
Okay, we are moving on to the second problem. Okay, so this is an interesting one. So see, this is just, the task is just to do simple word problems like this, right? And the setting is quite clear. You have a sequence of words again, separated by a space. You just need to do this arithmetic operation and return the value. Right, so you can look at the test cases for more help. So 1 plus 2 plus 3 should give you 6, minus 1 plus 2 minus 3 should give you minus 2. So has anyone solved this? Can you raise your hand, please, to solve this?
Sir, I have.
Okay, quite a few.
Yes, sir, I have to solve this.
Okay, so we look at, hopefully there are like few approaches, different approaches maybe that we can look at. So can someone paste your solution in the chat? I will just copy it and I will present that. Okay, Afnan has posted, so I'll maybe look at that first. Sometimes this happens. I think you have to use Zoom's copy. Nice. Okay. Okay. Yeah, you can go ahead, Afnan. You can explain.
All right. So we are initializing a tuple containing all the numbers from 0 to 9. And one thing to note here is that the positions of those words represent the number itself. So at 0, we have 0. At 1, we have 1. At 2, we have 2, and so on and so forth. And I've defined a function called toInteger of t. It accepts a list, basically. T is a list. So if t of 0 is equal to minus, we will return the number converted to its integer form and multiply that with minus 1, because the coefficient was minus. So that's why we are doing -1 here. Otherwise, we will return the positive version of that. So I hope this is clear. And then we are taking the expression input and splitting it by space, since the total on the complete expression is separated by space. So we have taken that. After that, if the length of the expression is even, is odd, we append a plus sign at the beginning. That is just to make sure that the entire expression is of even length. I'm doing that because in the next what should I call it? In the next section, actually, we are taking pairs of these actually the numbers are represented. Can you excuse me, sir? Can you please go to the test case first so that it'll be easier for me to kind of explain it actually. Yeah, so thank you. Thanks so much. So yeah, so let's see this first case. Here we have -1.
One second, I just paste it.
All right. Yeah. So actually, if we see the test case, it will be easier to explain. Otherwise, it's a little bit of, yeah. So what happens is, apart from the first integer, the rest of them always will have a sign. So like in this case, we have -1. So the length, if you pay attention, you will see that it is even length. Why it is? Because every integer comes with its sign. So it's like -3, +2, like that. But the first one, if it is positive, then we'll omit the minus. I mean, we'll not write anything. Like for plus, we don't write anything. So that's why, to make it even, I have put a plus sign. If it is not minus, then I have put a plus sign there. Otherwise, it will be minus, so it will already be even. Now, in the last part, what we are doing is we are initializing a result variable with 0 as the initial value, and looping over the expression, taking pairs of the words. So it's like -1. We take that first and convert that to integer form. We then take +2 and convert that to integer form, and sum all of them together. So that will be the result. I think it is clear enough.
Yeah, very nice.
But I think I was not able to explain it properly.
No, I think it was clear, but others can please ask your questions.
Yeah, if there is any question, it'll be.
So any questions?
Yes, I have a question, sir.
I didn't understand this.
I also didn't understand.
So please,
Excuse me, sir. Can you please
It's a very
execute
difficult
this
to
one second,
understand.
sir, so that we'll just
Yeah,
verify
yeah.
that it works. Yeah.
Yeah. See, not understanding is fine, but you must be specific about what you understand. I'm sure, like first line, you understood what it is. It's a very novel way of mapping integers to words, right? So you must, whenever you say you don't understand, right? I totally understand. You can. It is okay to not understand, but you must be specific in, say, I didn't understand line number 2 or line number 1. Then it becomes easier for the person who is explaining to address your query, right? If you say generally I don't understand,
here where we are accepting the input means -1, +2, -3, like this, where we are accepting that. In which line we are accepting that as the input? Okay, in line number 10.
Yeah.
Input dot split. Then next thing that I wanted to ask this, how the expression, or why this if length of expression mod, why we are checking it whether it is even or odd, that I didn't understand.
Okay, wait. We'll clarify that. So Afnan, you want to explain or shall I go ahead?
Would you like to take it up, sir?
Okay. So all right. So see what this is again a good way to, maybe this way he wanted to have the test cases with him, because that kind of explains it in a better manner. So if you look at both these test cases, right, for each number, maybe except for the first one, each number is preceded by a sign, right? So for example, 3, before 3 you have a plus, before 2 you have a plus, right? For 1 alone you don't have a plus, right? So in this case the length is what? Length is odd, right? So we have 1, 2, 3, 4, 5. Whereas in this case, you see before each number you have some sign, it's minus, plus, or minus, right? So here it's 6, right? So if the length of the sequence is odd, then it means the first item in the sequence is a number, right? It doesn't have, because it's +1, we generally ignore the plus, right? We don't need to say it's +1. So that is why he's adding this, he's inserting plus at the position 0 if the length of the list is odd.
But why only plus?
It is plus, right? Only if it is
Okay, +1.
I would-
Okay, the integer. Okay. If it was minus, then
that we would have given. The minus is explicitly has to be mentioned, so that if it had been minus, we should have mentioned it in the test case. And if it starts with minus, then it has to have an even number of elements.
okay.
Okay, is this point? I hope this point is clear. Now, what? Any other questions now with this?
Sir, this integer. Sorry, this t which is passing, where it is mentioned. I mean, the t is a list.
It's not mentioned, but it is implicit from the code that it is a list.
No, but how we are assuming that this is, I mean, how we are implementing this t in the function definition.
There is no implementation, right? Function definition assumes that t is a list and it proceeds with that.
Sir, why we use input function, sir?
You have to accept input from the user, right?
But in case of functions, input will be directly given.
No. See, that you should not see. Here we haven't asked you to write a function. That is one thing. So Afnan is using his own function to make his life simple. Okay, so the question nowhere asks you to write a function, but here it so happens that writing this function makes life easy.
Sir, can we use the concept of dictionary here, sir?
Yeah, we can. Yeah, we can use that also. We'll come to that solution. But is there any more confusions regarding this particular approach?
Hello, sir. Sir, after this, I mean, whenever we are inserting or whenever we are giving input at this exp input, at that time when what here we have written here, t of 0 is equals to minus, then if it is at third place, then will it take that third place as a minus or return -1 into num index t of 1? I mean, I didn't understand that part only. No.
This two integer function accepts actually a list of two numbers, right? So it is two, no, not even two numbers. It is some sign, comma, some number. Okay, so it could be let's say -3, right? Or it could be plus.
No. The doubt is whenever we are giving this as an input, where it is diverting that to this function, that two integer function. Here we are, suppose here we are giving -1 plus 2 -3. At the third place minus is there. Then here two integer. Okay. So every time it will reduce it and then okay. Now I got it. Okay.
Right. So yeah. So this is any other questions regarding this particular solution?
Hello, sir.
Yeah.
Sir, I couldn't understand from line number 20.
See, line 20, what's happening is, if you take up this particular case, this is actually the input, right? So the input now is exp equal to plus, okay, just ignore the strings part. I'm not going to use strings here because I want to save some time. So this is what the input will look like.
Yes.
So in each iteration, what we are doing is we are picking up two words at a time. So in the first iteration, we are picking up minus comma 1 and passing it to two integer.
Okay.
Okay, and then we are increasing the step size to 2. So after index 0, we go to index 2. So now we will pick up these two values, plus comma 2.
Okay.
And then 0, 1, 2, 3, 4.
So we
Yeah.
Two things at a time. Two things means -1. So first we are computing the value of -1. Then we are adding this to the result. Then we are computing +2 and then adding to the result, right?
Exactly. Yeah. -1 +2 -3. So he has, what Afnan has done is he has broken up this problem into computing the expression of each pair of symbols. So -1 +2 -3, and then he's adding them all together.
Okay, and when there is no sign before this one or any number, then he's adding a plus sign because it's obviously there is a plus before that.
Exactly. Yeah. Yeah.
So okay, understood.
Okay, so I think we have to stop explaining or working with this solution at this stage, because I hope it is reasonably clear. So Afnan, one request: can you paste this in or post this in discourse?
All right, so I'll do that.
Right. So this is a very good solution.
Thank
It's
you,
a good solution for several reasons, right? So this is a very good mapping, where you can use a dictionary, but this kind of naturally converts maps a word to a number, right, using the index. So this is a good one, and the use of functions is also another good one. The third thing is to kind of look at this connection of breaking this sequence into two batches of two symbols and then computing the expression. So these are all characteristics of a very systematic approach to solving the problem. So yeah, now we'll move on to any other solutions. Maybe one other solution we can look at, and then we have to move on.
Sir, a general question.
Yeah.
In line 1 for mapping, here we are using set. We can also use list, but I want to know the best way, set or list.
Actually,
tuples.
Yeah, tuple. So see here, tuple is better. List is not wrong, but the reason he has used a tuple, at least the way I see it, is tuples are immutable, right? So you don't want to mess with any of these values, right? For example, 3, inadvertently you might do somewhere, say num of 3 plus equal to, say 4, something like this. Then the entire string will get changed. Whereas if I try to execute this, you can see the error that it throws because it's a tuple. Okay, so I have some unwanted stuff here. So tuple object does not support item assignment. I think item assignment, right? So what it means is that you can't modify elements of a tuple. So this mapping is like fixed, right? So you better go for a tuple and not a list here.
Okay, sir. Thank you.
Sir, I did it, but it is a long code because I step by step. Anyway, that is not a good one. I pasted, but that is a very long code. I could have make it very small, but not using function. But
okay, right. So in that case, I'll go for maybe Shivansh has posted one using dictionaries, and I want to discuss a dictionary solution because the official one is a dictionary solution. So let me copy that. Okay, so I'll just break this up just so that it fits into a page. Okay, so yeah, Shivansh, you want to explain your solution?
So first of all, I would like to apologize for being so unsystematic. I was just creating it line by line. So sorry.
No, it's okay. It's okay. See, in this course, you have to write code. So if you can write systematically, that's added bonus. But as long as it works, it's fine.
Okay, sir. So I had taken the input on the first line and split it with a space because according to the question, we needed to split it by a space. Then I created a sum variable which would at last store the sum of the expression that has been given to us in words, and then only the numbers I took in the dictionary. The keys were the words that were used in the expression. They have already been split into a list by the e.split method. And the keys are referencing the particular numbers that they showed. Like 1 is referencing 1, 2 is referencing 2, and so on. I tried to use for loop with this, but it didn't seem to work so well. So I decided that I would use a while loop here. So I had to create I is equal to 0 from scratch. Unlike in for, you can simply say for I in range, because for creates the variable that it needs to count with.
Right. Yeah.
So I use then if e of 0 in dictionary, because that was the only thing differentiating the two types of expressions that were given in the test cases. The first word was the differentiator, according to what I did. So I thought that e of 0, if it is in dictionary, that means if it is a number, then if it is in dict means it is a number. Then I added it to the sum variable, which I had defined in line 3, sum is equal to 0. Just like the previous solution had added the plus variable, I instead simply did what it would have done if it had encountered a plus there. So I simply added it first.
Right.
Then I set I is equal to 1, because we have seen the first word with this sentence. If we see it again in a for loop, there'll be a problem. So I incremented I to 1, because we've seen the 0th value. If in case we had not seen the first one was not a number, then I will check it can either be plus or it can be minus. If it is not a number, if it's not in dictionary, that means the first word at the 0th index can either be plus or it can be minus. So I checked it inside this else block.
Right.
So yes, sir. Then the sum is equal to sum plus dict of e of 1, because this time the second word, the one at index number 1, was actually our first number.
Right.
So I use the plus according to e of 0 and added it to and used it to add it to sum.
Right.
We have already seen the first and the second word, which was at index number 0 and 1. So I now set I is equal to 2, because we'll now work with the third word. We have already seen the first and second word.
Right.
If e of 0 equal to minus, I could have clarified it. So once again, I would like to apologize. This could have been elif 1 e of 0 equal to minus. But since there was no other option other than plus and minus, I used an else.
Right.
So here, so clearly it starts with a minus. Say the expression was minus 1. The first two words were minus 1. So it will take sum is equal to sum minus the dictionary value of e of 1. E of 1 would be the number in words. It will check it from the dictionary that 1 means this number is there.
Right.
And subtract it from the sum which we have got right now. We won't have got anything. So this will probably give us a negative number, because it was 0 earlier. And once I had done that much, I had to set I is equal to 2 here as well, because we have done 1 and 2. If we repeat that, the answer will be wrong.
Right.
We've already checked the first two words. So I said while I is less than length of E, the first expression.
Right.
If this third value, which is at index number 2, E of I, equal to plus, because we have already checked the number. If we had started with a number, I would be at 1 only right now. That means we would be checking the second value.
Right.
If it would have been a plus or minus at the start, we would be at the second value. So setting I in this way took care of me having to change it inside the while loop.
Right.
So if E of I equal to plus, because after this we'll only get the first plus or the first minus. So sir, then it's simple. I just added it to the sum if e of I equal to plus. This next one, e of I plus 1 would be the number, like plus 2.
Right.
So it will check the second value and add it from there. 2 means the number 2. So it will add it to the sum which we have got till now. If it would have been minus, then the else clause will run. It will subtract the same. However, now we have checked the two values and we need to take care of that as well. So I incremented it. In while loop, it is your responsibility to increment, unlike in for loop, where it checks value by value from the list or range that it creates.
Right.
And
so,
yes, sir.
So you use this, right?
Yes, sir. Sorry, it's a bit unsystematic, sir.
No. It's. I think it's fine.
I have one doubt in this, sir.
Yeah.
This is line number 13 required because he's already taken care of the plus sign in the line number 9. So then we just need to take the either plus. The minus is the only alternative, right?
That's a fair point, right? So Shivansh, you want to comment on that? So if the first entry is a number,
yes, sir,
then it is you have already taken care of this particular block, right? So
no,
I could
no, sir. If the first value is a number, that's why I say it's in the else clause. It will not execute if the if clause executes. This whole block will be skipped in a sense if it starts with a number. If it doesn't start with a number only, then it will check whether it's plus or minus at the start.
Okay, so you are coding for the situation where the first plus 1 kind of thing could occur, right?
Yes, or minus 1 kind of thing could occur.
Right. So see, I think so. Vivek, the point is we could have some test case like plus 1, plus 2, plus 3, right?
Yes, sir.
Right, sir. Okay. Right.
So that is why this particular if block is needed.
Sir, I think the whole condition is being taken care by while loop. Line 12.
See, that cannot be right. So, for example, you are saying skip all this and just go to the while loop.
Yes, sir.
See, what if the first element is not plus? See, you have to start from I equal to 0, right? If you go for the while loop, and then what if e of 0 is say 1 and not plus?
E of 0 is 1, then the if condition will take care of it.
No, right? See, this if else checks if the symbol is plus or minus, and it is assuming that e of I plus 1 is always a number.
Sir, if first element is number 1, 2, 3, then this will be taken care by the if condition of line 9. And if it is not the number, then it will taken care by the while loop.
Okay, so yeah, so see, the general idea is correct, but if we have to check which to remove, right, that might take a bit more time, but the general idea is kind of okay, I feel. Right, so I agree. So maybe you could have reduced some of these conditions here and there, but that will, make us go into some more detail into this piece of code, which I don't want to do it at this stage.
Yes, sir. No, sir, this is it.
Yeah, so I think it's quite detailed. Yeah, right. So he's taking care of all special cases first and making sure that from some stage, precisely from I equal to 2, it's all plus minus or plus 1 minus 2. It alternates properly. So that is the point of this if else blocks. Right. So we have spent 1 hour on 2 problems. We have to now move on to problem 3. So problem 3, can some of you raise your hands, those who have attempted it and solved it? Okay. 4 of you have solved it. Okay, so let's.
Sir, I'm failing one test case.
Okay, then maybe you can you paste your code in the chat box?
Yes.
We can look at that first. Okay, so those who have not seen this problem, I'll just quickly go through it. So you have a steel rod whose selling price is a function of its length. Okay, so this is f of L, nothing but f of L, and you can make at most one cut of the rod, right? And let's say you have a 5 meter length rod and you make a cut at 3 meters, then you will have two resulting rods, one of length 2 meters and another one of length 3. So you can sell them for 40 rupees. Or I mean, so okay, 40 rupees, so 40 units, whatever, right? It could be 4,000, whatever. So 40 units is what I meant. If you sell it for, if you don't make any cut, right, you would be selling it for 3 units, right? But you're allowed to make exactly one cut or no cuts. So that is what it means when we say you are allowed to make at most one cut of the rod. So the question is, it's like an optimization problem. You have to find the maximum revenue that you can obtain, assuming you can only cut at integer points, right? So this is the general statement of the problem. Let's look at okay, the solution. First, I have other solutions also. I have noted them. We will come to that. We will first look at this particular solution.
One doubt in the question before.
Yeah.
In the input test cases, only the prices are given. So is it assumed like the length is the first one is 1, then it is 2? Okay.
True. Yeah. So I didn't mention it, is it? So
yeah. In the test cases, it is just given the prices. So we have to assume that the first is 1 meter, second is that so?
Yeah. So see, the second line is a sequence of L integers that correspond
the selling price. You can move to the test cases, the example. That's where I'm asking.
Yeah. So this line clarifies what the second line of the test case is. So it corresponds to the selling price of
rods of length. Okay. Yeah. Given. Okay.
Yeah. Okay. So yeah.
Sir, one clarification.
Yeah.
If the length of rod is 5, then either we can sell 5 length rod or 1 and 4 or 3 and 2.
Yeah, only these possibilities are there.
Okay. So may I explain?
Yeah, please.
Yes, sir. So we are expecting first the length of the rod and then the input and then
yeah, please go ahead.
Oh, yes, sir. And then converting it into init. And then initializing a dictionary and sum with a list. Then what we are doing, so the dictionary will, so can you go to the test case, please?
Just copy this.
Yeah, so the dictionary will be like 1. Yeah, so the dictionary will be like, for the length 1, the price is 10. For the length 2, the price is 20 and so on.
Okay.
And I'm initializing sum with an empty list and then looping through and then initializing dictionary, basically. So for I in range 0, length of the rod, D of I plus 1 equals to L of I.
Okay.
Updating the dictionary.
Right. Okay.
Yes, sir. Next, we are checking for which combinations we can get the length of the rod. If it is 5, then we can get it from 1 and 4. If it is, from 1 and 4 and from 3 and 2.
Okay.
And we are appending that tuple in this list sum.
Appending, okay.
Yeah. Then we are initializing values as an empty list, and then iterating over the list sum for x comma y in sum. If d of x plus d of y is greater than d of length, that means if the rod that we are breaking is if the value of the rod that we are breaking is greater than the actual length, that is if price of the 1 and 4, the length of the rod is greater than price of the initial length of the rod.
Okay.
Then we are appending that value to the value list.
All right. Okay. Okay. If not, you are still appending the same thing, right?
Yes.
Okay. So see, the general idea is correct. So the general idea of the solution is correct. But
Yes, sir.
what we can do is we can actually, I'll just comment this out and just point out this fact, right? So this is correct. So length is the length of the rod, and you are accepting the list, and then you are populating the dictionary, right? So till this it's perfect, and this could be made simpler. We'll come to that, but this also is not wrong. But why is I less than j?
Simply to avoid the 2 and 3 and 3 and 2.
That is fine, but you shouldn't avoid, let's say the rod is of length 4. You shouldn't end up avoiding 2 and 2, right? Right. So that's something. So I would probably say it is better to
Yes, sir.
have something like this.
And in line 12 and 13 also, length is checking one less. So length plus 1.
Yeah, but that is perhaps not a problem, right? So you can only go to length minus 1, right? So I can only go till length minus 1 for any rod, or it could also be 0. So that's a fair point. So we will come to that also.
But
right?
sir, we can't take 0 length rod, right?
So what I meant was 0 length rod would be a full, that is, you don't cut the rod at all. So it will be the same as d of L.
No, I am just saying, sir, number of iteration in this case, one less.
Right.
That is the only thing.
Yeah. So see, what I would have, what we can do here is till this dictionary, I will take up your code, and what we can now do is for say L in a range of 1 comma length. So you are cutting at L, let us say. So if you're cutting at L, what will be the price of the first part of the rod?
Sir, L is the length of the rod.
No, length is the length of the rod. So L is the place where you are cutting, right?
Sorry, length is the length of the rod.
Yeah, length is the length of the rod. So if you're cutting it at L, then what will be the length of, what will be the cost or revenue that you obtain from that portion which you have cut off?
Price times the length.
That is true if you have a linear rod, right? So your price varies linearly with the length of the rod. In this case, the function is given to you, right?
Oh, we have to integrate the product over each range.
Karthik, can we just go through the price and take the maximum price? So will it not be the correct answer approach? Because we need just the price, right? Maximum revenue. So we can go through the price and pick the to maximum and add it, and will it not be the correct approach? Because why do we care for length actually here?
Yeah, I'll come to that.
But
yeah.
Yes, sir. We can create a dictionary with the key as 1, 2, 3, 4, and the value would be the price. Then we will make every possible pair of sum of the price, and the biggest sum will be the corresponding key will be the value.
Right.
The
So
length.
yeah, so I'll come to that. So I just whatever Kushi's solution is there, right? I just want to. It's not wrong. So it is more or less there. I just want to finish. I'll finish that and I'll come there, right? See, this approach is correct. You are going through each pair of links and you are making sure that it adds to the length of the rod. That is important. And also this line is important because otherwise you'll end up counting unnecessarily. You'll end up counting, say, if the rod is of length 5, 1, 4, 4, 1, you'll be double counting, which is, or you'll be counting it again, which is something we don't want, right? So instead of that, maybe I'm not making myself clear. If you are cutting the rod at, say, okay, let me put it this way. Okay, so I am cutting the rod at this point, at point 2. So what will be the revenue that I obtain if I sell these two pieces of the rod? 40, right? So when you come to this for loop, I am cutting the rod at the point L. So what will be the revenue that I obtain from this cut? Using the dictionary, you have to tell me.
Sir, D of that L.
D of L, right? So D of L is the value of the rod of length L.
Yes.
So what will be the value of the other rod, other piece of rod that you have, remaining piece of rod?
D of L length minus
Length minus L.
Right, so it is D of length minus L. So this is the sum, the revenue that you obtain by cutting a rod at length L. Okay, so this is some value or this is some revenue. Okay, but this is where I want to go till what Shomit mentioned is correct. You have to go till length plus 1. Why? Can someone, or maybe I would even do the following. I would say go till length by 2 plus 1. Okay, this takes care of this I less than or equal to j. Do you see that?
Yes.
Yeah. Yes.
Right. So now you want to find the maximum revenue. So how do you do that? With this, you just need to modify this code somehow. How do you modify that?
It defines one max equal to say 0.
Okay.
And you check now if D of this length is revenue is greater than max value, then you define the new max value.
Okay, so that is all, right? So this is not, this approach is more or less there. So you don't need these the other part of code. So you can just stop it at this stage. So let's.
Sir, I just complicated things. So
That's fine. That's
ended
fine.
nesting of this.
Yeah, so this nested loop you have to avoid wherever possible. Nested loop, you have to make sure if you don't get caught in that. So
it actually turned out to be much simpler.
Yeah, so this is still passing only 3 out of 4. What is missing?
The boundary conditions will have to check.
Yeah, so what is missing? Can someone
So actually I did the same thing, but I didn't use the dictionary. But again, for me also it is only, I checked many times, 3 out of 4 only passed. I don't know why.
No, so we
So
are
line number 9, is it length plus 1? Line number 9.
Yeah, length plus 1, L of 0, but L of, you don't have an L of length, right?
The last value is not included, right?
Yeah, so we are, I think, missing out on the entire length. So the full length of the rod, right?
Yeah.
So we are missing out on that part. So we could fix that by starting from 0. No, not starting from 0, just having one extra condition here which states that if Maxwell greater than D of length, or if maxval is less than the length, right? Then maxval should be this we are not checking, right? Okay, let me just check. I am also not sure if that is the problem. Okay, so that's what we were missing.
So
Excuse me, sir.
Sir, can you
I add
explain a
something?
bit?
Sorry. Sir, can I add something?
Yeah.
Why don't we initialize Maxwell to be the actual original length?
That's
and then
a good
we don't
point.
have to check again.
That's a good point.
That's what I did actually. Yeah, thank you.
That makes it simpler. Okay, is this clear now? Okay, so either you don't cut the rod at all, or you cut the rod. So that is what this whole thing means.
Makes sense. You can't cut a rod of length 0 and make money.
Right. Okay, so let me do the following. Let me just.
Sir, just can you check mine, because I am not able to pass only one.
Yeah, I'll check yours, but what I will do is I will just quickly rewrite the whole thing. Okay, so you're accepting the length of the rod, okay, and you also have the distribution of prices, right, which is input dot split off. You're splitting by comma. I suppose that is what we have, right? So please bear with me. I just so that. Okay, and you are defining a dictionary for I in range of length of the distribution, or rather, since we have L here, I in range of L, we'll call this P, right? The price distribution. So the price of I plus 1, or maybe just to make it clear, the price of cutting a rod at I, or price of the rod of length I, is equal to the distribution of I minus 1, right? Now the maximum revenue that you could possibly obtain is something, right? But it has to be at least equal to the entire length of the rod when you don't cut it, right? And that corresponds to this: when you don't cut the rod, if you happen to cut the rod, then you could make the cut anywhere from 1 until say L by 2 plus 1. You also have to make sure when the rod is of even length, you have to include that part. So that is why this plus 1 is there. The revenue is P of L plus L minus, P of L minus L.
So in line 9, do you have to give L minus 1 or L?
It is L, right? I mean, I am starting from 1 to L. So.
Okay. Gotcha. Yeah, makes sense.
Right. So revenue is greater than well equal to revenue, and then you go ahead and print the maximum value. Okay. So I'll run this, and then you can let me know if there is anything which is not clear, or what is this? I made a mistake somewhere. Can someone point it out? We forgot to convert them to integers. Okay, so is there, before I move to the other solution, is there any confusion or anything which is unclear about this approach? Anyone? Anything unclear, not clear?
Excuse me, sir.
Yeah.
Can we do it without dictionaries also? I mean, what is the benefit here of using the dictionary?
Yeah, true. You can just use lists and then do length of list minus the index. Right?
Index from the index itself.
Yeah, fair enough. Yeah, you could.
Yeah. Okay,
Sir,
that is
please,
what
will you,
is.
sir, please check just mine, sir. Why I am not passing one test case? I just pasted the code.
Yeah. So I will come to that. So is there anyone having a doubt with this? Then let me know.
Sir, I simply use the find a maximum value of the list, and by that approach, I solved this. Is that fine?
Just maximum value.
Maximum value of the list.
In just maximum value, how will it work? Like 20 is the maximum value.
Yeah.
But you have to return 40, right?
Yeah. Sir, and after that, find the maximum value, and after that, break the rod into the index of the maximum value. According to the
That
index.
could be dangerous. See, maybe then our test cases are not correctly configured. How do you know that? See, this is length 2, right? And this is length 3. It so happens that here length 2 and length 3 are side by side. So if you break at 2, the other part is 3, and that happens to be 20. So you get 40. What if it's like, say, 10, 20, 5, 3, 20?
10, 20,
5, 3, 20.
5, 3. Sir, I think in that case, I can break in multiple ways.
I am not sure, right? So this needs some more thought. Can you start a thread on discourse with this? I want to see if this just going by the maximum will work or not. I am not sure at this stage.
I have already posted it in the chat.
No. Paste it in Discord so that we'll get back after the meeting.
Okay, sir. I will.
Okay. Yeah. Length is for I in range of length of L of I. This is fine. Again, see you are I think missing this, not making a cut. I think that is I don't see any other problem mainly.
Sir, I didn't get you. What?
So this uncut rod, right? So you don't cut the rod at all. So you are you counting that somewhere? You are not counting that, right?
No, it's means 2 loop means it is cut it, sir.
Okay.
On line 10, I think.
In line 10.
Yeah.
When it is 2 loop and I'm adding that means it is splitted in 2 part. And I'm just checking the maximum revenue by satisfying the condition I plus j equal to the length.
Correct, but I think you are not checking for the no cut condition.
Yeah, that is what I was also talking about. Are you checking?
Yeah, so
you
have to initialize the maxi to like the
instead of
to
0
like the to the cost of the max value. Sorry, the length, the full length.
Yeah, so let's just try this. I hope this will fix it. Yeah, so that was the problem.
Okay. But if I do since I have defined the max equal to 0, that is why I am not able to get that. Okay. Thank you, sir.
Okay, we'll move on to subsets. So this grew out of a very nice discussion that we had last meeting a week back. Okay, so we have to write a recursive function that will print all subsets. So the subset usually we use it only for set, but I hope the idea is clear from the question. You have a distinct list or a list of distinct integers, and you have to generate all possible subsets of that particular list.
It's like a power set function.
Yeah, you have to, exactly.
Yeah, okay.
So has anyone solved this? Can you please keep your hands raised, those who have solved this? What, no one?
Sir, normal way I have tried, but recursive way it is not coming, sir, for me.
So this question is something else.
Okay, so there is one Rahul Agarwala. Rahul, have you solved it?
Yes, sir. I have partly done it. Let me just paste it in the chat box.
Okay. Yeah, sure. We can see.
Sir, I just had a question before you start.
Yeah.
So if there is a question asking write a recursive function to do this, so recursive functions are those functions that call themselves, right?
Yeah.
So a particular function or a code that we have written will only be correct if that function calls itself within its own body, or indirect recursion also works here?
Preferably within its own body. I think if not, I don't think it will work.
Okay, sir. Just wanted to clarify that.
Yeah.
Yes, sir.
Okay, so Rahul, can you share it in the chat?
Yes.
Yeah. Okay.
Yes, I have just left out the DS part.
Okay, if the length is empty, then sorry, if list is empty, you return the set. Okay, it seems fine.
My logic here is any list given, say 1, 2, 3. So what I have done is I've considered the first element to be the fixed one.
Okay.
I've taken the first element as one, list one subset. List of the first element as one subset.
Okay.
Then I have paired the first element with all the other elements. Those all will be the subsets. Then I have taken the first element with two elements.
Okay.
Like say one list of one is one subset. List of 1, 2 is one subset. List of 1, 3 is one subset. And list of 1, 2, 3 is one subset. Since I have paired the first element with every other element, the recursion step will be I'll be removing the first element.
Okay, but how do you know J is a subset? I mean, how do you know that J is an element of the list? See, in the test case, it so happened that J is one of the elements. But in general, how do you know that J is an element of the list L? Oh, sorry. You are okay. You are going through the this I and J. Usually, you should reserve it for indices of the list. Okay, because we are so used to seeing them in matrices, while looping through matrices and lists. I got confused. So this J is an element. Okay.
Yeah. But I have not cleared all the test examples.
Okay, so the idea is correct. So let me just explain the idea. Using again bits or binary digits are very useful in this case. So let's say the list is say 1, 2, 3, 4, 5. Okay, again whatever you mentioned. So you can divide the subsets. So there are like 2 power 5 subsets, right? You have 2 power 5 subsets. Each item can either be present in a subset or not. So it is 2 into 2 into 2, so on, 2 power 5, 32 possible subsets are there. And this will include the empty set also, right?
Yes.
So now the nice way to look at it is exactly 16 of these subsets will have the number 1. And exactly 16 of the subsets will not have the number 1. Okay, is that idea clear?
Yes,
sir.
right? So you are just breaking the subsets into two sections, one which has the element 1 and one which does not have the element 1. So it's in some sense very close to what Rahul has done. Okay, so Rahul, I will take the liberty to delete the code for now, and we'll get back to right. But the idea is very clear. So I will probably retain what you have done here. The recursive call will look very similar to this. Only thing is, I may not do all these things.
Okay.
Okay, so I'll write the we'll start from ground up, right? So we need to find all subsets. So I will directly go to this part, right? So L of 0 is not there, or it is going to be there, right? So what I will do is, for each subset, I'll call it sub, in the subsets of L of 1 and so on, or if that is confusing, I'll just say rest is everything after ignoring first. Okay, so first is L of 0. So in the subsets of rest, what have we done? We have ignored L of 0 totally. So these are all subsets of L, mind you, but they don't have L of 0 in it. So there are two possible subsets that you can generate, right? So let's say you're going to hold all your subsets in another list, say S. I will just write this and you tell me if this is clear. Does this make sense?
Why this line number 8 is not append sub?
So these are all subsets that have the first element. These are all subsets that don't have the first element. This is 16, this is another 16. Together they should make 32, right? Is this clear or it's still confusing?
Sir, will it add the first element and an element from the rest?
Sorry?
Sir, when this because in the for sub in subset of rest, from this subset of rest, actually the function called again, right? So
yeah,
it will suspend and then again call again suspend, again call again, like that. After completion of all these things, then will it start yielding one by one sub?
It will always work. It will go ground up. So it will start from the last. So it's like the branching that you saw, right? The branching image that was shared on discourse, where you go all the way till the final branch, end of the branch, and then you build up from there. Okay.
So here for sub in subset, sub will be an integer value.
Yeah.
Sir, in every call, the as will be initialized again.
Sorry, sir. Yes, please.
Yes. Yeah. Someone was like, two of you were speaking.
Yes,
so
sir. In every call of the subset, the hash will be initialized anew.
It will be initialized anew. Yeah. It will be. See, for every call, you are dealing with a different list, right?
Yeah.
Okay, so just this part, any doubt? Is there any confusion?
There is no base case.
Yeah, we'll come to the base case, but is this recursive portion clear?
Not really. Is it still trying to understand?
Every time there is a recursion, S will be initiated to an empty list.
Yeah, every time. So S is going to hold hold all the subsets of L. Right. So see, you must for a moment suspend all thoughts about other recursive calls. Just look at it as you want all the subsets of L. Okay. So by calling this subsets on the rest of the elements of the list L, somehow, say by magic or whatever other means, you have all the subsets that don't have first element. Okay. But by definition of subset, this is also a subset of L. So you just go ahead and append it. This represents one half of the subsets of L. For the other half, you have to append this first element, or you have to insert it in every subset.
Sir, is it possible to take one example of small 1, 2, 3 and this iteration, how the subset of rest get built and append?
Yeah, sure. So we'll come to that. Then we'll finish the base case. Then what could be the base case?
If it is empty list, then return a list of
Return
empty list.
Empty. Yeah, return empty.
Then it will read list of empty.
Empty of
List of empty list.
Right. So if it's empty, you return a. Okay. So let's run it first. I also don't know if this will.
Sir, one question.
Yeah. Once again, I'll just make sure that this is correct, and then we will proceed with the. Okay. Unfortunately, only 3 test cases are there, but it's okay. Yeah.
Sir, in every new call, the list as is creating a new, and then what will be the value that we previously append to it? The as will create a fresh new, or it will just replace the old and set it to empty?
S will be a totally fresh new list. For this particular call, it will be a new list.
And what about the previous call? The S in previous call?
That will be some other list that was created for that particular call.
That means in every call we are creating a new variable.
Yeah.
It is returning, sir, S only. So that S will be S dot append first plus sub list, or S dot append sub that list.
Sorry, I didn't get the question.
We are returning a list S after appending it with first element and after appending with other than first element.
Yeah.
So the final S will be which one? The subsets will first element or the subset without first element?
It will have both, right? Because that is how we have we have partitioned the problem into 2 parts. One is all subsets which have the first element, which will be this one. So once you get hold of all these subsets, you just have to add first element to that, and that will be one collection. And then you just have to append that particular subset as it is without making any changes. Okay, so maybe this example might help, but I don't know how well I can explain this. Let's start with
1, 2, 3. Oh, okay.
1, 2. Let us make it very simple and see what happens. See, then this is going to call subsets of 2, right? Okay, so when it comes here, it's nothing would have happened. Yes corresponding to this still empty. It would have called this. So when it calls subsets of 2, what happens? It will again go and call the empty list, right? So this will return a list of empty list, right? The empty subset. So now at this stage, I'm focusing on this call, right? So what is happening in this call? What is returned here is the list containing an empty list. So you append first 2 to the empty list, which is just the element 2. And then in the next line, in line number 10, you append the empty list itself. Okay, so the second call will return this particular list. that clear?
So once more, so just.
Sir, once more.
Okay, see, what is happening is, unfortunately for recursion, we don't have a nice way of visualizing immediately. I have to go and draw images and then come back, which will take time. So when we have 1, 2, what is happening is,
Sir, please take one more element.
hey, that
Sir,
will confuse people.
Sir, just one idea, sir. Is it possible to show it in means by import PDB and trace so that the arrow gate moves and you explain? Will it be helpful?
Actually, I don't know PDB, so that's the problem. So
Sir, we can use this website that I have shown in the chat to visualize the recursion.
Is it, what is the website? Python tutor, huh?
Yep, sir.
Okay.
Yeah, sir, we have to just edit this code to ours and then we will be able to visualize it.
Okay, let's try it. Edit this code. Okay, so I should click on visualize execution. Huh?
Yeah, sir, just comment out.
I have to do this.
Yeah, you have to call. Yeah.
Okay. Okay. And then I
Sir,
have to,
you have to click next for every step.
okay, this is nice. We will see how it goes.
You can add one more number, it will be much more clear now.
Yeah. So just
right.
Let me just let us see how it works. So we have now entered the second call, right? Now we are returning at line 3. Okay. Yeah, so this will take some time for me also to follow. So, but this is a good thing. I'll keep a note of this, right? So what maybe I will do is as you suggested. So I'll just try this out, but see, the sequence of calls is like this, right? So that much I think you must know, which is, this is the sequence of calls. Sorry, not 1,
2,3, sir.
2,3, right? This is 2,3. So are you clear about the sequence of calls?
Yes.
Okay, so
Yes, sir.
moment you are clear about the sequence of calls, the return value should also be clear. So the return value here is this, right? There is no, this is the base case. So it will hit the base case here. Okay, now you are just taking each element of this returned list. Note that the subsets of rest will be the returned value from the call that is below you. Okay, subsets of rest for this particular call, subsets of rest would be what? The returned value from here. Okay, so I am adding 3 to that particular element and I'm appending the empty list as it is. So this is what I return at this stage. Is this clear? So if these two are not clear, then we can't understand any of the other things.
It's clear.
First element and the rest.
Yeah, so now for this particular call, subsets of rest is going to be this return list. Okay, so what is the first element here? 2. So we are adding to each of these elements, we are adding 2. So 2 comma 3, 2, and in line number 10, we are just appending these elements as they are. So 3 and the empty list stay as they are. Is this clear so far?
Yeah.
And now we just complete the whole thing. So for now, for this first is nothing but 1. So to each element of this returned list, we are going to add 1 to it. So we'll do 1, 2, 3, 1 comma 2, 1 comma 3, 1. Okay, and then in line number 10, what we'll do is we'll just retain the whole thing.
Oh, nice.
Okay, is this clear now? Is any part of this not clear?
Sorry, it's clear, but we need, I think, more practice. Or
Yeah, sure. This can be, see, this is tricky because it is actually, it will look like magic at some level, because you are offloading all your computation to some kind of hidden process. It's like you are just saying, okay, give me all the subsets. I will just add my first element and I will just use the other subsets as they are, right? So it's like very little effort from your side, and all the hard work is being done at the background.
It's like a new type of recursion.
Yeah, this is like a very new one which maybe we haven't seen before. Okay.
Excuse me, sir. I'd like to add one thing. I think it often helps us to think from the base case onwards rather than going to the base case from the start. Like the way you did from the last one and then came back. So that helped a lot. So
Right.
Start from the start and then go to the base case, it becomes a little bit unclear. But if you do it the other way around, it is much more clearer.
Right. So so that in fact is a very important point, which is the relationship between what is called as induction in mathematics. So induction in mathematics is very closely tied to recursion in programming. Right. So do you all remember induction? You would have studied it in Max 1 early on.
no, sir, it's not
proving, right?
Maybe in 10th or 11th week.
So in 11th and
yeah, in 11th.
Okay. So see, the idea of induction is what Afnan was mentioning about starting from the bottom and then building up. So how do you the famous example that they give is you have all dominoes, list of dominoes, or a sequence of cycles arranged in this order, and if you just push the first cycle, then everything to its right will fall, right? So assuming that you push the ith cycle in the line, it is guaranteed that the I plus 1th cycle will fall, right? So if you have an infinite line of cycles, and if you push the ith cycle, then for every integer I, all these cycles will fall, right? So that is induction, and that is very closely tied to recursion, right? If you think about it, we are actually inductively building up this set. So we are starting from the empty set, and then we are adding just one element, and then to those subsets we are inserting one element at a time, right? So anyway, this is my.
So if I go to the instead of recursion, if I want to solve this problem in iterative way, then first I will take the empty set and then build on.
Yeah, you
just opposite.
Right. You have to
empty, then I put that empty set in first element and copy the empty set. Now this become the new set, and again I will put it and then put one element and build on like this.
Exactly.
1, 2, 4, 8, like this.
Exactly. Right. So maybe that explains this. That explains this approach of. So you have Fibonacci, right? So a Fibo of n, you start from top down. So you assume n minus one and n minus two are computed, and then you compute n. Instead of that, you start with f0, f1, and then you get f2 by doing f0 plus f1.
Right.
So yeah, that is the difference between these two approaches.
Excuse me, sir.
Yeah.
One other question, related question. The other question is, like in this line number 12, we have a for loop. So that is calling the subset function, which is itself, it is fine. But I suppose that the function call, the original function call, which is actually calling the subsets function, will be suspended until that function call gets completed. I mean, when it returns the value, then the previous one, the caller one, resumes. The function call that called the subset function resumes only after the next call returns its value, right? So
Right.
if we start, and then so it's like everything is suspended until we first hit the base case. Only after that the rest of the calls get processed in some sense.
True. Yeah.
Okay.
One more thing here.
Yeah.
Say the list has some repetitive elements. Say the list is 1, 2, 2, 2.
Right.
So in that case, there will be subsets in this to this process. We'll be getting some repetitive subsets in the list, right?
Yeah. True. So this is actually, that's why it's kind of, I mentioned earlier, right? It's dangerous to call it subsets. That's why we have mentioned that it should be a distinct list of distinct integers.
Okay.
Right, because actually we are representing a set as a list. So that is why the complication arises. Okay.
Nice problem, sir. Nice one.
Yeah. So this, I hope we can move on now to M5. M5 is.
So 5 is very dangerous problem, sir.
Okay, why?
Because my computer get hang, sir.
Okay, so you tried recursion?
Not recursion, but using later on I think on recursion, but initially I try to do with for loop. But first test case passed, and then it is so long, then I'm not able to, the computer get hangs.
Okay.
And when I paste this code in the portal once again the first test gets passed, but after that they say timeout.
Okay, so what is your, so has everyone like seen the question, please? Or do you need some time to process it, others?
Yes, haven't tried it yet.
Sir, just I had a doubt,
Yeah.
general doubt. Sir, we have seen that we can take an iterative problem and express it recursively. So, sir, is there any algorithm or a way we can, the way how we think of a problem so that we have an iterative solution and we can convert it in a sense to recursion?
See, I don't know of a general formula, but from what we have been doing, right? So whatever problems we have configured, the usual approach is to so again, I'll go back to this idea of induction, of shrinking things, or the reverse of building up, right? So I start from n equal to 1, and then I slowly build up one step at a time. So in recursion, you think of it like I want to reach n, but I have n minus 1 with me. So how do I go from n minus 1 to step n minus 1 to step n?
Okay, sir. Makes sense.
Okay, so this, yeah.
Thank you, sir.
Yeah.
Excuse me, sir.
Yeah.
I had a query in P quiz. I think I have already asked in the previous week also, but yeah, in P quiz 2 I had a problem. So in this question I am only able to pass 3 out of the 5 test cases. The public ones are passing. So I just wanted to know what what is the I mean what the other cases are not passing, but I'm not able to figure out what is the exact
Which one?
P quiz 2.
Quiz 2.
Yes, sir.
Okay, so maybe
This is a
we.
simpler one, but I think something, perhaps some sort of a edge case or like that.
Okay, so maybe see, I think others. So others you haven't looked. Most of you haven't tried solving the 5th and 6th problems, right?
So 5th and 6th I solve it. 5th I tell you the problem that I am facing. 6th is okay. I have done it.
So can we please discuss the
Same here,
fifth one?
sir.
Okay. So Afnan, we'll probably come to this after we discuss the 5th one.
All right, sir, no problem.
So 5th I'm just pasting my code. Just check, sir, why it is happening like that.
Okay. So where is your code? We will look at it. See this, if you are going to use square roots, it's dangerous.
So do we have to use binomial expansions or something?
You also don't need to go till there, right? So see, if you have to deal with integers, okay? So if you are not going to deal in integers, it's a problem. If you take square root, then that's problematic, right? So you have to, in this particular problem, you have to think a bit mathematically before going to the programmatic way of solving.
Yeah, initially I thought that expansion and take the coefficient I should go like in that way.
Okay, so this is where the whatever I was talking about as induction will help a lot. So this expression is there, right? So let's take this. I won't give the solution, but I just present this idea to you and you tell me if you can take it from there. A plus b power n, someone is telling you that it is of this form, x plus y into square root of p, right? This is given, this is in some sense given to you, right?
Yeah.
Now, so I will, this whole idea of pushing the next cycle, I'm going to do that here. So what I'll do is, once I have computed the value of something power n, the next logical question I am going to ask is, what is the value of a plus b root p power n plus 1? Okay, do you see any connection from here? How you can take it forward from here?
So that a plus b whole to the power n into a plus b.
Okay, right. So this is correct. So this is the into a plus b square root of p. Okay, so far so good. Now what?
This is a recursive function. So
okay. So from these two equations, can you tell me something that could happen?
Yeah, it's recursively occurring, right? That a plus b.
Right. So recursion is one approach. I could call the function on n and then multiply that by a plus b root p, but still there is, let's say, let's not think about this recursively now.
So there can be a for loop which will run n times. Every time I'll multiply like a multiplier, multiply by a plus pp, right? So that's also another.
Sir,
yeah, that is fine.
Yeah.
Are you saying, sir, in the next step I should write x plus y root p into a plus b like that?
Exactly. So see, we have already seen that this is x plus y root p. So why not use that, right? So just a plus
b root p.
Okay, now what?
Now, sir, I just plain multiplication and
Okay. Okay. Can you tell me the two parts? So what will this be?
Sir, one is
ax
plus byp. This is one part.
Okay.
Another one is root p into ay plus bx.
AY plus BX. Okay. So this so far so good. So with this, can you now solve the problem? See, you start with you start with a plus b root p, or you start with x plus y root p. And then the moment you multiply that with a plus b root p, that becomes ax plus byp plus whatever. Does this give you any idea?
Matrix multiplication. I don't know.
Yeah, but maybe we don't even need to go there. So what about sorry, this copying doesn't work. So what about a plus b root p power 1? It is just a plus b root p, right?
Yeah, same thing. Yeah.
Okay, so now I compute this once. Initially x is equal to a and y is equal to b, right? And then if I keep multiplying this with a plus b root p, x and y becomes what? Ax plus byp and ay plus bx. Okay, so let me go back. I think I am not making sense. So what I will do is I'll just solve this, put the solution out there, and we will discuss from that step onwards. I'm just going to plainly copy whatever I have got here. Ax plus byp. Okay, there's one way of ax plus b into y into p. And what is the second part? Ay plus bx. So this is my x and y. Initially, what is my x and y?
A and b.
Okay. So I just loop through n minus 1 values. I don't want n equal to 1. N equal to 1, I just return x and y.
That's the solution.
Yeah, I just want to make sure that this is correct. So you are not subscribed. I click back button. Please click back button in exam. Don't click go to dashboard. That will take you out
No,
of
but
the.
for me, when I do the back button, it is going through the previous program. This is not working all the time.
Oh, is it
Some
not?
things
Oh,
work.
okay.
Yeah.
Yeah, then we have to fix it. very
Copy, actually, at least save it, but I keep forgetting to copy it. So we lose the code.
Right, right. Then yeah, submitting it, then copying it, I think is the only way. Okay, so yeah, so this is the solution. Do you now see why it works, or?
Yeah.
Okay,
I'm
so
just multiplying I am just equating the coefficient.
right,
X plus y. Okay.
right. So see, this is one class of problems where you rely on your mathematical knowledge and then piggyback on that. So you don't do everything computationally. You don't use Python for everything, but maths helps you half the way of the journey, and then for the rest of the journey you use Python. So for example, there's no way you can do this mathematically, right? I mean, of course you can sit and multiply and do all those things, but for this number crunching you need Python. However, for figuring out this relationship of how do you go from one step of the iteration, see, this is basically you are in one step of the iteration, you are going to the next step of the iteration, that's all. So any questions here? Did you were you able to follow this?
Not yet, sir.
Okay, which part is not clear?
So line 4.
Okay. So yeah, that. So what is not clear? This mathematical portion is unclear.
Yes, sir. Mathematical portion.
Okay. See, you start with this. This much is clear to you. Assume that you know that this thing happens. That if you raise this to the power n, then it is just x plus y root p.
Yes, sir.
Then if you raise it to the power n plus 1, it is just the same as multiplying it by a plus b root p again.
Yeah, correct, sir.
And then you already know that this is x plus y root p. You just multiply that with this. This is just basic multiplication. And you see that this form is maintained. See, that's the important part. Something plus something into root p. That is what this is. Something plus something into root p. Right? So this is all I am doing. You start with x plus y root p. You multiply it with a plus b root p. You end up with some expression like this. I keep on doing this again and again n times.
So is it related to matrix multiplication? If you multiply eigenvectors, so it will remain parallel. Just doing scale transformation.
I am not sure. So what will be your vector here?
Initial vector is x and y. Let's say, whatever, like if you are.
Okay, if your initial vector.
1 and root p are my eigenvectors and x and y are eigenvalues.
Okay.
Then if I multiply lambda, then this is, I don't know, this is where.
Okay, it seems, yeah, it seems similar. So 1 root p, I agree, but this lambda is not the same thing, right?
Right.
So, yeah, but looks close, I would say.
Basically, it's not changing the direction. It's coming out parallel with a different scale.
Right, true. That is true. That is true.
That's the lambda stuff. What?
Yeah.
You can project it to the unit circle, then it becomes. But here we're not doing the standardization. That's why it takes a different form.
Right. Okay, so if you have.
Hello, sir. Just a moment.
Yeah.
There is no concept of n in this iteration, right?
N is there, right? So you have to iterate over it n minus 1 times. So.
Yes. Every iteration will give a different x and y. So subjected, the number of iterations is dependent on n. So, but the n is nowhere related to the coefficients or the values.
N is, see, the value of n will influence the coefficients, but not in. It will influence, right? So if someone was mentioning binomial expansion, so if you actually expand it binomially, you will n value will come somewhere here. So that n choose k will.
We are multiplying n times, but how that n is incorporated or expand in the expansion, that's I was thinking.
N implicitly comes, right? So you don't explicitly mention n anywhere here in this line, but the very fact that you are repeatedly doing this n times will introduce n somewhere. So it's this question is a mix of mathematics and programming, right? So that's where the whole difficulty will come in when you try to understand this. So
this operation will repeat n minus 1 times essentially. That's how the n gets factored in. So that
exactly,
range,
yeah. It gets factored in like that. So it's kind of implicit. So I don't explicitly see an n anywhere here, but it's going to be there somewhere.
So the last x and y will be the last iteration of the n, or it will publish every time?
No, it will be the last, the final updated values of x and y.
It's nothing but the nth value. When I equal to n, then that time what is the x and y will be published out.
When I equal to n, actually see in fact I can even remove I, so I could just replace it with some random variable.
Yes.
Right?
That's not matter. I'm saying that when the last iteration happened, the values available in x and y will be published out.
Yeah, that will be returned to the console. And
so there is no accumulation of earlier values. It is taking only the last value of, it's nothing but n value in the last one.
Actually, every time the value of x and y is getting added for every iteration. We are doing a cross x and b cross y. So every time I'm assigning it to x and y. So every time the value of x and y is getting added only then we are getting the correct x and y value and we are returning at the final iteration.
Right. So you are updating the value of x and y in each iteration. So this thing is called a simultaneous update. So you are assigning this to x and simultaneously you are assigning this value to y.
Okay. In next iteration, the existing a cross x will have the older x, which is already published out.
Which is, yeah, which the value, whatever it was there in previous iteration, that value will be there here.
Okay, got it.
Maybe if we add a print statement inside the for, it will be better understand.
Yeah, so then what you will get is you will get different, yeah, you could try that. So I that is a good suggestion, but I don't want to do it now because this might become very big. But so if you can see for x plus, this is like 1 minus 1 plus root 2 whole power 50. So this is the value in when it is power 1. This is when it's power 2, power 3. So until the final one. Okay, so that is.
We are not calculating the nth power of a, b, and p. A plus b square root p. Am I right, sir?
We are not calculating
the nth power of the a plus b into square root of p.
That is what we are doing, right? We are calculating the nth power.
I think we are only calculating the value of x and y.
But that will be, see, the beauty of this whole expression is that no matter to what power you raise this, it will always be of the form some number plus some other integer into square root of p.
Yes, sir. We can use x and y to calculate the final value, but we only need x and y. That's why we are only calculating the value of x and y.
Yeah. Only x and y we need because that is all matters. The root p will stay there for y root p.
Yes, sir. I gave it 1 hour, but I was just calculating the whole value and then trying to extract the value of x and y.
Okay. So that will create problems because moment you say square root of p, you enter into floating point operations and all that.
Yeah, that's the point.
Okay, so maybe we are actually nearing the end. So has anyone attempted M6?
Yes, sir. Completed.
Yes, sir.
Did it, sir.
Okay, so this the ant. So those who have not attempted, maybe you can drop off if you want to try it and then and not see the solution now. But I just for the sake of completeness, I will complete. So I will discuss the solution to this problem also. Okay, so see, you have an ant that is sitting somewhere in the grid and you have a foot source here. The ant can move only in two directions, up or right. So you have to determine basically if the ant can reach the foot source, and if it can reach the foot source, how many steps does it have to take? So here it takes 5 steps, whereas in this particular grid world, it can never reach the source. Okay, so how do you represent this world? It's just a matrix of strings. Wherever the ant is, it will be B, and wherever the foot source is, it will be green, so G. All the others are white cells, so you represent it by W. Okay, so this is the problem setting. Yeah, so whose solution should I take up first?
Can I dictate?
You can paste it so that I can copy it from there.
Okay, sir, paste it.
Okay. I have two solutions, right? One by Shomit and okay, so maybe I'll take this solution first. I will just introduce few spaces. This is just my own idiosyncratic way of dealing with code. I like these spaces. Okay, so can you explain the?
Yeah, just idea is to since in the matrix everything is white other than only 2 points. So I try to figure out the coordinate means what is the I and j value of that initial position and final position. From the matrix I get that and check the simple logic with the up and right direction and put it there. In the very first, initially in row and in column I introduce in that fashion, because if the matrix is not the square, if it is irregular also, then also this thing will work.
Okay, okay, nice. So yeah, see, one thing, you don't need this, right? You don't need to find the absolute value, right?
No, I just
Okay, but
sometimes if I make the which one to which one, then it may give the negative also.
Okay, okay.
That is why.
Okay, so does anyone have any questions with this particular solution?
This is like computing the Manhattan distance.
Yeah, exactly. So it is the grid distance or Manhattan distance between these two cells. Okay, anyone else? Any questions regarding the solution or? Okay, I think some of you have not seen the problem, so maybe you can watch this after you try solving or attempting the problem. Okay, so that might make more sense. So that completes this particular part. Now I will just go to pquiz 2 and solve that particular query. So Afnan, can you post your solution here? I will just.
Yes, sir, doing it.
So just one one small thing. Now, since we know this, how to generate the subset,
right?
The question that we initially that discussion, can we now to go to that problem and find the coordinate? What are the various possible combination that can give that number?
Yeah, sure. Yeah, with that we will close. That will be the last point.
Okay.
Okay.
Excuse me, sir. I have posted that in the chat box. Could you please take a look?
Yeah. So this Takshari problem is you have split the word. So by any chance, was this there in your exam, like your batch?
I don't remember this, sir. Maybe it was there, maybe it was not there. I don't remember.
Okay.
Yeah.
Okay, length of words. Okay, so whenever you have words of, so the if condition is correct, but you are we take the test case, otherwise the two, three, four, five. Let's say it's round. So for I in range of length of words minus 1, when you come to 4 and this will be Same. So you increment by 1. So it becomes 2. See, I have one question. Why didn't you place this?
Actually, sir, what I am doing here is I am incrementing and incrementing till we reach, a non-matching pair. So if till the point it is matching, we are incrementing the count. But once we get a contradiction, we reset the count to 1 again. So, and then we take the maximum of that.
Yeah, no, your code is correct. So it looks correct, but I'm wondering where it could go wrong.
Yeah, the public ones are actually parsing, so I was not able to figure out what was the, because the private test cases 3 out of 5 are parsing, but 2 out of them are not parsing. So I don't know.
Okay, so this is a good activity for others also to step in. I'll just.
Sir, one question. What if there is no subsequence of Antakshari?
Then it should return 1 by default. So that it's anyway doing, right? If there is like, if there is no, it will return 1, right? So it will print 1. So that is this particular test case. So the public one, 1, 2, 3, 4, 5. So this seems to be correct. So that is not the problem. So something else should be the problem. Let's just check. Okay, so let me just do this. So you have A. So we have A, then sorry, and B. So when you're here, count is 1 to begin with, but count will become 2 when you go here. Count will become 3 when you go here. Count will remain 3. Okay, but the moment you go here, count is back to 1. Now so I just want to make sure that the normal test cases are working. So what should be the output here?
Should be 4, I think, sir.
Before, right?
Yep.
So sorry, I don't want to submit. I just want to see, these are actually good exercises because can write the correct solution, but sometimes we also need to know how to debug Still errors like this, or I don't even know if there is an error or we have made a mistake. We have to see. So this should print 4, right? So expected printing, why is it printing 1? Okay, I'll try this in the replit, okay, because I can't.
I think you have not split the strings. Actually, we are handling a list.
Oh, okay, okay.
Yeah,
So
that is why.
I will just go here because it's slightly more useful for this kind of activity. Yeah, yeah. Okay, so we are splitting it, and so this is the usual thing is working fine, where you have this occurring somewhere in the middle. Okay, now what happens if it so are others tuned in? So any suggestions you can please tell me, because I'm also trying to figure out any ideas, any test cases that you think might break the code.
Excuse me, sir.
Yeah.
Perhaps if we can see the solution first, the any solution which is working fine, which is passing all the private test cases, and then we can perhaps compare to see what could be the difference.
Okay, see if I
yeah, because I was not even aware of the right solution.
Yes, sir. My code has passed all the.
Okay, okay. Yeah, I will take up your code, but yeah, just one small thing. I have a gut feeling that for whatever reason, I feel that if this is here, this might help. But I'm not sure. Okay, so. Okay, so
So the other branch was fine. I don't see the reason behind it.
So see this in CT. In fact, in CT, while I was framing a the exact question, but not in this form, in some other form, we actually.
Aldear block.
Yeah.
Okay, go ahead. Actually, in Aldear block, you just now shifted that else statement into inside that if loop, because earlier what happens, even though the first thing is not means true, then it is coming to the else part, right? So from there, from there, because suppose my count is instead of 1 something else, and in the next for loop, if it is go to the else block,
okay,
if it is go to the else block, then
Okay, all right. Yeah, I got your point. Yeah. He's trying to say that, okay, if it is some sort of a off by 1 error, because when we hit the contradiction, we don't increment by 1. So we should increment and then check for the count. So what happens is that in the other cases, somewhere it happens the test case that we have to, like, for example, if we have to go to 4, we are at 3 and we kind of update the longest, but the count was not incremented because the if condition was not evaluated at that point, because we directly jump into the other branch. That is one possibility. Yeah.
Okay, so I don't. So it will help if you could have that concrete test case where. So you're saying.
Maybe you can you try one change, sir, here?
Yeah.
So what you do is longest is equal to count plus 1. Do that only. I think if I have understood the problem, then it should be fine. Yeah, then try to run it. No, it's not that.
Yeah, so
Sir, we can do one thing.
Yeah.
Excuse me, sir.
Yeah.
Here. So we can do one thing here. First, we take the first we find the position of the blue. Where is blue? Like for matrix, first we i's in the range of length of matrix and j in the length of matrix. And where is if mij is equal to blue, we will take the position of I and j. And again, we will take the position of for the G. Where is G?
Yeah.
And then after we will do the next step. We can do the position of B, position of ith position of the B plus uh, jth yes, G position J position of G minus J position of B, and we add that with these two positions.
Right. So you're talking about that ant problem, right?
Yes, sir.
Yeah. So actually, so we kind of moved on to this one other problem.
Okay. Sorry, sir. I
Yeah.
thought that on the
Right.
Saturday, sir.
Yourself.
Perhaps if I can see the test case that is failing, it would be like more illustrative.
Yeah. So see, in fact, I made the same mistake when I was preparing one question for CT. In fact, in the first run of CT, we released that question, and we had to make one announcement correcting it. So I did the same mistake of adding the max checking part into the else block. So that's why I remember that it has to go into this. So but still,
Actually, it is
yeah.
losing the longest value. Suppose in the midway of your iteration in the for loop, suppose count is instead of 1 something else, say 2, 3, whatever.
Okay.
But that now this count is greater than longest. The longest supposed to hold that 3 value, but here it will not done because count loses this. If this if block, because it will never come, because it will come to the else block when the condition of the line number 7, if condition fails, then then the else block will execute.
Correct. So can you, that's what I'm asking, you seem to understand the problem. Can you translate it in terms of a test case so that I will also follow it? I am now currently lost. There's one correct test case, if you can come up with it, and that will give your explanation more power.
Okay.
So you are saying that for if count is not 2, right? So let's say AA. So if it is AA, then count would have become, longest would have become 2, right? No.
Yes.
So now longest is 2. So now what you're saying, what should be the sequence of words?
Now you say, sir, first longest equal to 3A.
Okay, longest is now 3 A's. Okay.
Now you followed by 2 B's.
Okay. So count would have been reset to 1.
Just check this condition, sir.
Okay. You want to try this, run this and see. Okay, I suddenly went to that. This is better. Repeat is better now. Okay, you have to see, this is initially 1. When it sees this, it already becomes 2, right? So the moment, even in the first index, first iteration, count becomes 2. Right, and when it comes here, it becomes 3. When it comes here,
so after
B,
you add 4C. or 3C.
Okay.
Yeah, let's see what happens.
But longest would have already been set to 3, right? So,
No, you make it 4 somewhere. C is 4.
oh, C is 4. Okay, 4C. Now what? Now will this work? Okay. So the edge case is when the last sequence happens to end and when there is nothing to check if we have exceeded it, then you are going to end up with this problem.
All right. So it happened when the actual favorable case was actually the last one. So
last one, yeah. So you couldn't check
can
for
you
them.
please try one more thing? The
Yes.
condition itself you can kind of put into the sum. So what's I of y of -1, the condition, if condition, you can take that and then add that to count itself maybe, and then get rid of the else block.
Sin, like how do you want to change this?
I want to sum the Boolean variables itself.
Count. So count plus equal
Line
to-
number 8, can you please copy after if till the end? Yes,
then
copy
add
that
it
and
to
put
this.
into that count itself. Yes, and the else block will go away.
Okay.
And if will go away also, we'll only check for if count is greater than longest. That's all. It is should be fine, I think, now, because the branching case is not happening, so it should work.
But this else I need to still have the else for resetting count, right?
Is that the case?
So see, okay, I'll remove this count.
Yeah, we will reset the count. It is fine. But in the else block, why do we need that to be in the else block? If
no, not an else here. So it won't.
Directly, yes.
So if this is, I need this to reset count, right? Is there setting count?
Okay. So for resetting count, we need that. All right. Okay. Yes. Yeah. In that case, we'll require that. Okay. Got it.
Okay. Right. So this is a very subtle error there, and it can be tough to catch. So yeah. So with that, what we'll do is that one last subset.
Yeah. Sir.
We will discuss, and then we will close the meeting because we are already over time. So this is what we do to find all the subsets, right? So once we find all the subsets, what we do is, if we want a particular sum, and we want the sum of the subsets to be 3, then we can just do for subset in subsets of L, if the sum of that particular subset is double equal to S, we just print that subset. So that's what I was mentioning the other day. Sorry, what is happening? Okay, I don't want, I meant 6. Okay, so this is, of course, this is not an entirely recursive solution because subset sum is not recursive. I am using some other recursive function, that's all. Okay, is that clear? I mean, it's a trick. It's not a complete solution in the sense that subset sum is not recursive, but only this particular function is recursive.
Yeah.
Okay, I don't know a way in which that is a challenge. So can you write a recursive function called subsets of L comma S that will, generate this kind of an output? That is left to you as an exercise, and if you can find it, I'll be happy to know.
Okay, sir, try and post it in Discord, sir.
Yeah. Okay, so I think, yeah.
Sir, if possible, could you check my one code? I'm really struggling to get the error.
Okay, what code is this?
So programming quiz to M1.
Programming quiz 2 M1, this one.
Shall I share my screen, sir?
No, if you can paste it, it will be easier. I will.
Okay, okay. Just a minute.
Yeah, so with this, we are certainly closing. Okay, this is the last piece of code for today. Okay.
Sir, everything is clear. Just one doubt, sir. So here, at first instant, I couldn't get the idea to just do line 10 and get rid of that above from line 2 to line 9. Okay.
Okay.
So I did, initially I did from line 2 to line 9. And when I run this code, it is not passing one test case. And that is where I'm getting confused. Why isn't passing that case?
So this part is correct. I believe this part doesn't seem to be wrong. So in which case, I think whatever we just encountered, right, in the Santakshari case, when your character is space, you are appending S to the you are getting the word. So I hope your last word is not, where is your last word getting appended to this? See, you get the point, right? So your last word, so for example, if my paragraph is 1 space 2 space 3, if character is space, then you are, is not a space, you are creating this word.
Yes, sir.
So whenever character becomes a space, you append that word to L. So 1 you will append once you encounter the space. 2 you will append to your list after you encounter this space.
Yes.
So where are you appending 3?
You just enter after S, enter in last L dot append S. That's
Right. So this point is needed. Otherwise, see this is the interesting connection between this error and what we saw just now. So both are very close.
So, but how come it was passing all the other test cases?
Because the last word. Okay, 1 second. This is true. This is false. Is this false? Okay, I am overriding para. See, it was passing because the last word perhaps was not the word which appears in
yes,
time.
Yes, sir. Got it.
Okay, so that should work, I believe.
Sir?
Yeah.
I have used the count function for this one. So is that right?
Count is okay. See, unless we explicitly mention that you should not use, you can use.
All right. So I just use the count and checked if that particular word is equal to is the count of that particular word is equal to the given n.
Right.
Then will return true. Otherwise, it will be false.
Right. Yeah.
Right. All right. Thank you.
Okay.
Sir,
so
thank you, sir.
Yeah.
Sir, when we will receive all the relevant information email for the exam on Sunday?
I think, see, tomorrow you have mock, right? Tomorrow is mock exam. So, sorry, not mock exam, but this mock is there, right? I believe.
Sir, but we didn't get any mail regarding this.
Oh, okay. See, I also don't know. I need to check. So, yeah, but we will be getting it soon. That much I can see. It will be easier, much easier than last exam is what I feel from whatever I have seen. Make sure you manage your time properly and it should be fine.
Sir, can we expect questions from recursion, sir?
Yeah, all last 4 weeks will be covered properly. Functions, collections, recursion, and yeah, those. One was
recursion is pretty confusing, sir, especially the one we did today, the subset question.
No, subset question is too hard, right? So there are some questions called overhead transmission questions which go above the head. So that is one such question. So if you don't understand that, it's fine. At least now, if you don't understand, it's okay. But maybe you can go back and we won't ask such very hard questions in exam, which require you to think for like 1 hour before you arrive at the answer. So
Yes, sir, exactly. Sir, also can we expect questions like that in which we should use the mathematical knowledge also, like the question we saw on today?
See, if it has been covered in, say, earlier weeks of Max 1, like then I think you are expected to know, right? Because this is a part of the, see, this is a course in a program. This is not like a standalone Python course that you are doing. So too much mathematical knowledge we won't expect. That much I can say. Okay.
One
Yeah.
question I wanted to ask. Someone mentioned about this count function. I think Afnan did.
Yeah.
This count function, I found something very strange. If you're doing a count in string methods, if you put count, now suppose you count a string, say is, is,
Yeah.
and if that is occurring in this also, then it counts is out in this also. In the word this,
Right,
THIS.
Yeah.
Is it counting in that? Because I found it is counting in that also.
For that, there is one problem. You have to use the space when you go through the list. No, you should make sure split it with the space, so then it will not be get counted. Initially, we had this problem. They explained it. Yeah.
Okay.
Because this will be a word, and when you split it, that is you cannot. Otherwise, if you go by string, then it will be giving a mistake. If you go by splitting, then with space or comma, then that won't be counted.
When you go by string, you can add space in front and back of your string. Which was
So that way you will not.
So if I create a list, it means it'll be okay. If it's a list of words.
Usually, I feel that if you use a split, then it won't get counted because you're comparing as a word, right? You won't compare as a letters.
Okay. Oh, thank you.
Yeah. So yeah, I think we can close. I feel so.
One more doubt, Karthik.
Yeah.
I use that evaluation in that 1 + 2 + 3 expression because I have no clue how to convert the expression. So, but my test case is passed. So, but in exam, will we be allowed to use that built-in function?
Which one? Eval?
Yeah, evaluate of 1 + 2 + 3. The mathematical expression to integer to integer. Yeah, 1 + 2 + 3. That
for which problem did you use it?
For that 1 + 2 + 3 mathematical expression, plus and minus we were discussing today. I was not having any clue how to convert it. I struggled, so I searched and got that evaluate built-in function, and I passed the test cases. But will it be allowed in exam? Today I got the solution from the friends, but today only I watched how to do that process.
Okay, but eval, I didn't know that for minus plus, how does it convert it into minus and plus? Is there some way that it does?
No, I used dictionary, and I have put 0 to 9 and plus minus also in the dictionary.
Okay, so see, eval no restriction, but yeah, I don't see any problem.
Cause problem? Yeah, but here it passed, but I'm just asking because the code was very easy when you use it evaluate.
Yeah. See, this is our constant problem that we are facing, that how to make students not use certain things.
Okay,
right?
I agree, but this I didn't get a clue to, and that's why today I watched all the programs. I will go through it again, but that time
but eval
I
is
want to
fine.
solve it. So I used evaluate, and the code was very using dictionary and just evaluation was very easy.
Right. Yeah, that should be fine.
Okay.
So we aren't having any session till Sunday, right?
See, I wanted to know, how do you folks need any more sessions? Do you need any other revision session? Anyone here?
Sir, with questions, revision questions more.
That is tough, right? See that this 6 questions, that is all. So more questions I would also like to have, but then yeah.
So are we talking about this P quiz? Has that been discussed?
Yeah, we have discussed all 6 today.
No, not the program 2 quiz. I'm asking about the P quiz.
No, that we haven't discussed.
P quiz 1.
Yeah, so those we haven't discussed because like somehow it was left out. But
Are you going to release the solution for the P-quiz?
it was actually open for some time, and then we only recently we closed the deadline for it. I mean, like extended the deadline so that solutions will not be available. But I just want to know, tomorrow, would anyone want to have a session, or see, it won't be anything new? I won't be discussing new problems.
The P quiz, can they be discussed? The matrix one, I couldn't solve it.
Okay. Okay. Others?
Yes, sir, we can do that.
And tomorrow, sir, what time, sir? This
I
same
don't
time?
know. So, when is your tomorrow? What sessions do you have?
So can we make it in Saturday evening?
Yeah, Saturday evening. I was just thinking it will be too close to
Too
the.
close.
Okay.
Shamit will be too close.
Yeah. Okay.
Okay, no. What I was asking is, do you guys have any sessions tomorrow?
Not in the evening, sir. In morning.
If you think an evening, then please think after 7, sir.
Okay, so maybe we will have. I am not sure. I don't want to promise now and then cancel tomorrow. But we will see if we can have, say, 1 hour at least tomorrow.
Yes, sir, it would be better, sir.
Okay, we will.
Yes, sir.
Yes, sir. We'll restrict it to only 1 hour. Sir.
Yeah, we won't spend more time.
And sir, if possible,
quick
sir,
recap.
If possible, please release the solution for the P quiz.
Okay. Yeah, we will discuss PQs tomorrow. See, I am not going to do anything else. Only this. If at all we have a session, we will see if we can have one, and we will discuss only the programming quiz questions.
Oh, okay, sir. Okay.
Okay. So yeah, thanks for joining. We will.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah. Bye.